Welcome back. We are learning about the Thevenin theorem. We have solved multiple examples containing dependent sources and independent sources, and now we will look into the another very important concept, that is basically uh, computing the maximum power transfer in your circuit. So what does this mean? Like, let's say if we have a complicated circuit and we are basically attaching this is a pre-amplified circuit for a speaker. So like we have this is the source of basically the voice. Okay, and then you have this pre-amplification circuit, and here basically we attach our speaker load. Okay, so let's say this is the impedance ZL. Okay, now this whole circuit can be like, for example, we can get the Thevenin equivalent of this one. So now to ensure that the maximum power is transferred towards the load, the impedance, okay, seen by the networks, it must be complex conjugate of each other. So if we can ensure that thing, that will basically ensure that we have basically, so let's say like we get R Thevenin here. Now this R Thevenin and this load, it should be basically complex conjugate of each other. So if they are complex conjugate of each other, then maximum power will be transferred. Okay. So basically to get the maximum power transfer, you just need to find out the R Thevenin of your circuit. So once we know the R Thevenin, we need to make it equivalent to the complex conjugate, and we get our actual maximum power transfer. Okay. So this is just a further analysis to actually calculate a formula for the maximum power transfer. So like I said, okay, we need to ensure that the resistances are basically load resistance and the Thevenin resistance are complex conjugate of each others. So the power we can calculate by using the like voltage drop here. Let's call this VL and divided by the resistance value. And this is the simple voltage divider rule. Simple series circuit, we can calculate the VL using RL divided by RL plus R Thevenin times V Thevenin. Okay, or in other words, PL will basically will be this. Now, for the maximum power, okay, we can basically make a function of power with respect to the resistors. We take its derivative and we set it, the first derivative is equal to 0, do the simplification, that will basically give me this one. Okay, now if we put this thing within this formula, okay, so like RL is basically is equal to the R Thevenin. So like we have RL and plus RL here. Okay, so this will become basically 2 times of RL, right? So it will become 2 square. Okay, so we have RL here, so 2 square is basically 4, and again we have RL square times V Thevenin square. So this and this will be cancelled, so we have basically V Thevenin square divided by 4 times of RL or R Thevenin. Okay, so that is basically the formula to get the maximum power. Okay, so maximum power will be transferred if they are complex conjugate. And if you want to calculate the maximum power, so just take basically Thevenin voltage square divided by the 4 times of the R Thevenin. So in other words, shortcut, if you want to compute the maximum power transfer, calculate the R Thevenin, calculate the V Thevenin, plug in this formula and have it your maximum power transfer. So let's try to understand this with the help of an example. The question is here, calculate RL for maximum power transfer. So RL is basically the resistance load which is connected here. So RL means we simply need to calculate what? We simply have to calculate basically R Thevenin. So how we can calculate R Thevenin? By removing the load, okay, from the circuit. So let's remove it. And after that, let's draw our circuit. So our circuit will look like what? Okay, so this is our circuit. Okay, so this RL I removed. So basically I just want to find out what is the basically R Thevenin by looking from this end of the circuit. So just to find the R Thevenin, we have a independent sources here. Okay, so we can just simply, okay, remove those sources. So current source will be open. So again further I can redraw the circuit. I have 4K here, I have 3K here, I have 6K here. So this current source, it will be open. This voltage source, it will be short circuit. Okay. And we want to find out what is the resistance by looking from this end. So if you look at this circuit, what we can infer? We can say that basically this is the one node, this is the second node. Okay. So this 3K and 6K, they are in parallel, right? This 3K and 6K, this is in parallel. Okay. So we can simply get the value of our Thevenin here. Okay. So 3 and 6 parallel, that will give me what? That will give me 2K, right? So I can further redraw the circuit. Okay, this is 4K and this is basically 2K. Okay, this is open circuit, so basically no current flows here. So again, by looking from this end, so 4 and K are in series, so our Thevenin comes out to be 4 plus 2, 6K. Okay, so we got our R Thevenin. Okay, now the second question was, like, if you want to calculate basically the maximum power transfer, you also need to find out what is the voltage drop here, right? V Thevenin. Okay, so Thevenin is basically the voltage drop across 6K and 4K. So if you can find out basically what is the voltage drop across 4K, so basically Thevenin is what? Voltage drop across 6K times the current that could be flowing here. Okay, let's call this I2. Okay, and plus the voltage drop across 4K times the current that could be flowing here. Let's call this I1. Okay, so somehow, like, if you can find the voltage drops here, we can find basically all the Thevenin here. Now to get that, what we can do here, we can simply apply the mesh here. So let's say this is I1, this is the I2. Again, you can use different techniques. Okay, I'm just using mesh here because it will be simpler here, because I have an independent current source. Okay, so I1, I can find it directly. I1 will be 2 milliampere. So for I2, let's write the KVL here. So 3 times I2 minus I1, I2 minus I1. What is I1? 2. Plus 6 times of I2 plus 3 is equal to 0, right? So if you simplify this one, the value of I2 comes out to be 1/3 milliampere. Okay. So if I have value of I2, I can simply find the Thevenin. What will be Thevenin? 6K times I2. What is I2? 1/3 milli. Plus 4K times I1. What is I1? 2 milli. Okay, so that will be 6/3 2 plus 4 times 2 8, 10 volt. Okay, so we have our Thevenin. Now to get the maximum power transfer, what is that? Thevenin square divided by 4 times of R Thevenin. So 10 square divided by 4 times of 6. Okay, so it will give me a power of 25/6. Okay, this is 6K milliwatt. Okay, so that will be the maximum power transferred towards this load for this particular circuit. Thank you so much.